Afternoon. Thank you for joining today's Resideo webinar session, where we are going to be providing an overview of our hydronic zoning basics. My name is Jamie Quanrud, and I'm part of the Resideo Sales Training Team. And on behalf of all of us, I'd like to welcome you to our training session today. And before we get started with our technical presentation, I'm going to cover just a few administrative items for you. Please join us every Tuesday at 2 p.m. Central Standard Time, where we give you the opportunity to learn about our products. For a schedule of our future webinars on a variety of topics, please visit resideo.com/webinars and navigate to the tab named Comfort for more information on these webinars. Next week, we are featuring a training on our non-connected thermostats, as well as we are giving you a preview of our new E1 Pro and T3 Pro thermostats. So please register and join us for that exciting training next week. Additionally, we are recording each of our training sessions, and you can find these recorded sessions on the same website under that webinar recordings tab to reference at a later time. And for those contractors who are joining us for today's live session and you are interested in earning one NATE continuing education credit, there are just a couple of things to note. If you did provide your NATE ID on your registration form, we submit that information to NATE for your attendance of today's live session, and we don't need any additional information from you at this time. If you did not provide us with your NATE ID on that registration form for this webinar and you'd like to receive credit for attending our live session, we do ask that you email your first name, your last name, your NATE identification number, and the date of the session you attended to homes.university@resideo.com within 1 week from today. This information is submitted to NATE 1 week following the close of today's training. Any requests sent outside of 1 week from today cannot be processed. As a reminder, we can only process requests for NATE credits when you attend the live webinar session, and we are unable to process any requests for watching a recorded version of this session. If you'd like more information about the NATE program, please visit their website at natex.org. And then one quick note before we begin our technical presentation today, all attendees are muted, and if at any point during the technical presentation you'd like to ask a question, please use the Q&A feature found in your Zoom webinar controls. We are reserving the last 15 minutes of our time today to answer your questions. So as we progress through our technical training today, please be sure to ask your questions in that Q&A feature, and we'll be sure to address those at the end of today's training. Now we're going to turn over the presentation to Chris Parks, who is one of our water sales leaders for Resideo for the Western United States. Thanks so much for being here with us today, Chris. The floor is yours.
Thank you, Jamie. As Jamie had mentioned, my name is Chris Parks. I cover the Western United States, specializing in our plumbing and hydronic heating products. So today, we're going to cover the basics of hydronic zoning. I'm going to cover what products fit into different applications, different ways of laying out projects. But before we jump into all of that, I do know that we have a lot of people on the call today that come from a forced air background. So I wanted to start just with a basic explanation of what hydronics is. So hydronics is utilizing a fluid, usually water. Sometimes it's a water and glycol mixture as a transfer medium in a heating or cooling system. So instead of blowing forced air around, we're going to be moving warm or cool water depending on if we're heating or cooling. For the examples that I'm going to be giving in the presentation today, we're going to focus primarily on heating and talk about how we use hydronic heating in different applications. I'm also going to discuss the best ways to configure a system. We'll talk about that shortly, and then which products fit in those different applications. So we talked about zoning quite a bit in some of our previous webinars. So I'm not going to go down to the nitty-gritty of it, but a couple things I do want to point out is when we're looking at hydronic heating systems, hydronic heating is typically going to be high mass. It's not always the case, but a lot of times we refer to in-floor as our radiant system. So if you have an in-floor heating system, there's a lot of thermal mass. So it takes a long time to heat something up. It also means it takes a long time for something to cool back down. So as a result, when we look at zoning with hydronics versus forced air, that's something that we really need to take into account. Because if you get an area that has a potential for solar gain, you do run into potential problems with overheating. And that's one of the biggest problems that we run into with a hydronic heating system, is not necessarily that you can't get it hot enough, but the fact that once it reaches that temperature, it continues to radiate heat out of, in most cases, the floor. When you're looking at the basics of zone design, just like with forced air, you really want to start with a heat loss calculation to identify what your loads are in each area. But really, a lot of times it comes down to, what does the homeowner want? So when you're doing a design, make sure you're having those conversations with the homeowner. You know, how do they want to control an area? What areas do they want on their own thermostats? Do they want to break every room into its own zone? Do they want to combine? At the end of the day, making real small zones can complicate some of the operation of the system. However, keep in mind what you're trying to deliver is comfort to the homeowner. Radiant offers a lot of comfort over forced air in most applications. So in the example I have here, and we'll be kind of building upon this as the presentation goes through, but if you look down in the bottom left, I've got zone 2 and zone 3, which is 2 bedrooms and a bathroom, and we've split those zones in this example. There's nothing wrong with combining those zones either. It's just a different way of looking at it, different way of doing things. Certain areas of the country, people will put the garage on a zone, use something like a unit heater, just to make sure that garage doesn't freeze. But when we look at what it takes to actually do a zone, to create one and move forward, it's not a lot. There's a few products that are engaged every single time. So you have to have a thermostat that's going to tell the zone to come on and off. We use thermostat wire. We do have solutions for wireless, and we'll talk about that later, but let's just plan on thermostat wire for this application. And then you're going to use either a zone valve or a zone pump. And we'll talk about the pros and cons of different types of systems shortly as well. But thermostat wire, a flow device, and then some miscellaneous fittings. You're going to have some copper fittings, some packs, etc., to kind of make that zone up. So big ranges of pricing difference between thermostats. The zone valve or zone pump have pricing variations, but really when you break it down, it's somewhere between $400 to $700 a lot of times to add a zone. When you're doing it from a new install, it's not a lot of initial work. It's easy to lay out. So keep that in mind when you're adding a zone or subtracting a zone. The monetary aspect of it from a big picture is not real impactful. The other thing I want to touch on is domestic water. So when we looked at the floor plan, we saw 4 different areas in the example that I was using that we're going to break off to zones. So each one of those zones, as I had mentioned, is going to be controlled by a thermostat. But another piece that's commonly added to hydronic heating systems is what's called an indirect water heater. There's different terminology for these, but essentially it's, instead of using a gas valve or an electric element to heat a tank, you're actually going to use the boiler water. So the boiler is going to circulate hot water through a coil or even a tank in a tank, depending on the configuration. But there's no electric elements, there's no gas that's supplying this tank. It makes it incredibly efficient. Plus, you're using a boiler that has significantly more firepower behind it than what's typically supplied with a residential water heater. Most residential water heaters, we supply the gas valves for a lot of them. Most of our water heater gas valves come in at about 38,000 BTUs. Whereas if you look at a boiler, depending on the area of the country you're in, that boiler could be anywhere from 120 to 300,000 BTUs. I just picked an average of about 200,000. So if you look at the difference in firepower between utilizing the boiler and utilizing the gas valve that comes on the heater, very different in terms of output. The other thing I wanted to highlight is, again, talking about zoning. When we look at a thermostat, and keep in mind how that word is, thermostat, when we go to utilize the control for the indirect we have a sensor inside of there that's sensing, instead of air temperature or ambient temperature, it's actually going to sense the water temperature. The terminology we use for that is aquastat. So think of that as your water thermostat. So instead of thermostat, it's aquastat. It accomplishes essentially the same thing. So when the temperature of that drinking water in that tank drops below the set point, it's going to tell the boiler to come on and essentially heat that tank. Just like a thermostat does, when the temperature around the thermostat drops, it's going to say, I need heat, and tell the boiler to come on. So we want to take the domestic water into account when we look at zoning, because we want to treat it just like another zone of the house. It's going to be heating drinking water instead of the ambient temperature in the rooms. So one of the things I want to talk about now, and we'll spend a little bit of time here on the differences between zoning with pumps versus zoning with valves. Very different mentalities. They accomplish the same thing, the end result, which is delivering fluid and flow through the zones. But different areas of the country do things a little bit differently. And there's not necessarily a right or a wrong way of doing it, but I just kind of want to talk over some of the pros and the cons of utilizing pumps or valves for the system side of the project. So what I've got up here is a very basic and typical piping schematic, utilizing a modulating and condensing boiler, which is really kind of the trend that we're seeing the movement go to, is high efficiency boilers, and then an indirect water heater as well. So what I've got is I've got a hydraulic separator there breaking the flow characteristics between the boiler side of the system and the, let's just call it the tubing side of the system. In other words, the actual house side. So we're going to focus on the circle there, where I've got an arrow pointing to some of the pumps. So if we use a pump for every single zone, a couple of the pros, a big one, you've got independent flow device for every single zone. So if one of the pumps fails, this is a 4-zone system here. If one of those pumps fails, you're going to have flow through the other 3 zones. You've got redundancy. And in a worst case scenario, you could actually move those pumps around if needed to, in case you didn't have a replacement handy. You've also got the capabilities for very simplified circuit setting. And I've got with ECM pumps. So for those of you that don't know, ECM stands for electronically controlled motor. It's more commonly referred to as variable speed. So what's going to happen is that pump will actually ramp up or ramp down based on the actual needs of that zone or system. And we'll talk a little bit more about ECM pumps here in just a moment. So while you've got some pros there, there's also there's some cons when you zone with pumps. And I just want to touch on those because we're going to compare those to valves as well. A couple of the cons, you've got larger energy consumption. Now that is not taking into account utilizing variable speeds. Circulators, as those start to become negligible. But if you're using a standard fixed speed circulator, there is going to be a larger energy consumption than valves. The pump is typically oversized for the needs of the zone. Now, again, I'm going to throw an asterisk on there. That's not necessarily true with variable speed pumps. But again, looking at fixed speed circulators, which are more commonly used in zone pumping jobs, a lot of times that pump is dramatically oversized. As a result of all the fluid movement, you're also going to have increased mechanical room heat and sound, and it takes up more space. The pumps are bigger than valves, therefore they're going to, by design, take up a larger footprint in the mechanical room. When we look at our pump line, in a hydronic heating system, a lot of times we refer to them as circulators and not pumps, because we're not technically pumping water. If you're going to pump water, you're going to move it from point A to point B. But in a hydronic heating system, we're really just kind of moving the water around. So we're really circulating it. So you'll hear people call on a hydronic system, you'll call them either pumps or circulators. Both of them are referencing the same thing. But a couple of things that we do, all of our aqua pumps, we have 3 different models. All of them are wet rotor circulators. And what that means is the motor and the shaft and the impeller is all in one chamber that's filled with the system fluid. So in other words, as the water or antifreeze mixture moves through there, that's actually what's doing the lubrication of the actual pump itself. So there's no need to add grease, etc. for the maintenance on these. They're very simplistic circulators. One of the things that sets us aside, and this is very sought after on the service side is our twist to fit flange. When you're looking at these residential circulators, it's a 2-bolt flange attachment. And I've got an image there up on screen that shows those 2 bolts. The reason we did 4 is because when you're using wet rotor circulators, the motor needs to be horizontal, meaning that if you're looking at the black aspect of that pump, it cannot be staring at the ceiling and cannot be staring at the floor. It needs to be in the orientation that you see there in the image. If you don't have it in that spot, you're going to have premature failure on the pump. So that 90-degree, or call it 4-bolt flange, gives you the flexibility to put that pump in just about any replacement opportunity that you run into. So if you've got a competitor's product that you're pulling out and going to slap this in, some flanges are rotated 90, some are 0 degrees, so you don't have to worry about unsweating the flanges from the piping. You can leave everything in line and just put it right in. And then every one of our 3-speed pumps, or every one of our 3 models, is also a 3-speed circulator. So what that means is you've essentially these are fixed speed pumps, but it's almost like having 3 pumps in one. So you can switch between 1, 2, and 3 that's shown in the image, and it will actually change the pump curve and the energy consumption of that circulator. So it'll make it run faster or slower based on where you put their setting there. And you'll notice it's also, as a result, going to draw more wattage depending on the pump, because you're basically making it a smaller or a larger pump. Now, I had talked briefly in the previous slide about variable speed pumps. We have not had that on our product offering until now. So for those of you on the call, you're getting kind of a sneak peek of some products that are going to be coming out in the next couple of months. One of them is going to be our variable speed circulator. Now, I'm not going to go into too much detail, more to come on these, but it is more of a premium offering. I don't know that I would necessarily use these in zone pumps, although it can be used. I'll show you where this is going to fit in the next slide much more commonly, but you're going to have different settings. You can do auto, where the pump will actually learn the system, ramp up and down as needed. You can do proportional pressure, or constant speed. So it's going to have programming options built into that pump to really fit the needs of the system. And then kind of building on that, we're going to talk about zoning with valves instead of pumps. So same system, same dynamic. The only difference that's changed is that circle in red there again. So I've got the arrow pointing at our valves. A lot of times we see those on the returns instead of the supplies, but we have a single pump feeding those. This is more of my preference, and I can say that primarily because since I cover the Western US, most of the Western US zones with valves instead of pumps. But what we do with that is a couple of the pros: much lower energy requirement. When a valve opens up, it only draws about 7.7 VA, so very low energy consumption, and the serviceability is very simplistic. We'll talk about the zone valves and how you service them a little bit later, but there's not a lot to servicing the valves. More times than not, you can get in and replace the parts that have worn without ever having to drain any part of the system or even access the water component of the valve. A couple of the cons, though: you use one pump. So there are exceptions to that, but typically you use one circulator. And I'm going to talk about the differences between a fixed speed and a variable speed. If you use a fixed speed circulator, you have to size that to accommodate every single zone being open at the same time. And that can result in somewhat large circulators or pumps. The problem with that is if you get a large pump in there and you only have one zone opening and all the other, let's say in this example, the other 3 are closed, that pump is generating more flow than it should. So what you're supposed to do is add what's called a differential pressure bypass valve. It's basically a spring-loaded valve that you add as a bypass so that when you only have one zone open, that pump has called an exit strategy for all the extra pressure that it's creating. When all 4 zones are open at once, there should be nothing going through the bypass. When only one zone is open, it should have a certain amount of flow going through there, so it's not driving all that extra velocity through that singular zone. Now, as we've started to migrate more into variable speed circulators, that component becomes obsolete because the variable speed pump will actually ramp up and down as it sees valves open or close. So we've got 2 different sizes in our product offering for differential pressure bypass valves. It's our D146 series. But again, as we go into variable speed pumps, you actually don't want to use that because you want the pump to see the opening and closing of valves. But that's probably the biggest issue. And then also, when you've only got one pump feeding all the zones, if that pump fails, you don't have flow through any of the zones. Whereas with zone pumps, you've still got 3 other zones that are getting flow through it. So pros and cons to both methods. Again, I'm going to state that there really is no right or wrong way. It's going to depend on the job, and it's going to depend on your personal preferences. We offer solutions for both. When we go into our zone valves, I do want to highlight we offer lots and lots of different zone valves. I think between a couple of different series, we probably have somewhere in the neighborhood of 400 to 500 different zone valve configurations. I'm going to highlight today our V8043 series. This is predominantly what's utilized in radiant heating systems residentially. And I've got an image of one of our newer press configurations up on screen. The beauty of our zone valves is really what happens inside the water. So when you put this valve in, what you're going to see is you've got a Buna rubber ball. And on some of the full port valves, you can see it really well. But it's a rubber ball that sits on, call it an arm. And when you give that valve power, it's going to pull that ball away, allowing flow through the valve. As the water is moving past that ball, it's actually going to cause it to spin on that arm, so that when it makes its closure, when that zone satisfies, it's going to close on a concave pattern on a different spot on the ball every single time. So a couple of advantages of using this versus a ball valve style or a paddle style is, one, incredibly reduced potential for water hammer. Also, since that ball is closing on a different spot every single time, there's there's very little chance of wear and tear on that ball. What happens if you end up with a problem inside the water passageway, let's just say you have the zone valve get stuck, what usually causes that is bad water. So if you're not treating your water with corrosion inhibitors, if you've got hard water, if you've got oxygen permeation in the system, what can happen is that spindle that the ball sits on can seize up. It's usually only in rare instances that happens, but that can potentially happen. Which again leads me into talking about the serviceability of these. You can take the component off the top, the power head we call it, which is the silver piece you see in the picture. And then if you take that off, you do have access to that, call it the guts of the valve, without ever having to remove the actual product from the piping. Our zone valves, we've got lots and lots and lots of options. So just in this one series of valve, we have different voltage options. We have a 2-way configuration for flow through. We have a 3-way configuration for diverting. We've got a lot of different connection types: sweat, threaded, press, flare, inverted flare. Even the wiring, we got different options for your wiring. So you can do 2-wire, you can do 4-wire, you can do screw terminals, and then we've got different CV ratings, which essentially reflects the flow restriction through the valve. For North America, the most predominant valve, like if you were to go into a distributor and ask for a zone valve, they're probably going to instinctively go to 24 volts, normally closed, and sweat. That is by far our most popular valve. So if you want something beyond those configurations, make sure you detail that to the customer or to your distributor, because we offer them in normally open, normally closed, different voltages, etc. So you can check our catalogs. We've got lots and lots of different options. I did want to talk about tying everything together now. So we've talked about our zone valves for zone pumps. We've talked about thermostats being utilized to turn a zone on. We talked about aquastats. So the other piece is now we need to make it all connect. So one of the products that we offer is a hydronic panel. It's a very simplistic relay. I've got an image of one of ours up here on screen. And there's some big advantages for using this. One, I'll show you an image next, but you can see in the bottom right, that's pretty typical of a lot of jobs that I walk in on. You can wire everything together with a transformer. We're happy to supply you the transformers. We sell lots of them, and it's a much less expensive way to do it. I would strongly encourage everybody to utilize a hydronic panel. It's a relay that simplifies all the wiring, but more so than not, it makes it much easier from a troubleshooting standpoint. You've got LED lights. I'll show some of that on the next panel, but I just wanted to kind of show you how everything links together. And if you don't use a panel of some sort, a lot of times that's what you walk into, is that picture there in the bottom right. When you get into our hydronic panels, I want to now real quickly, since you got that picture from the previous slide in your mind, take a look now at the picture in the top left. So that's how clean you can make things look when you use a relay instead of an Aquastat. Plus, again, one of the big advantages I was talking about is look at your LED lights now. You can walk into a mechanical room and immediately notice if the thermostat should be calling for heat, if the zone valve should be open, if the boiler should be on, if the domestic water is calling for heat. You've got a visual representation showing you exactly what should be happening in the system. So from a troubleshooting standpoint, there's no need for me to necessarily get out my voltmeter. I can walk up and visually see exactly what should be going on. We make these in different configurations. So we have a zone valve option. We also have a zone pump option, depending on what your preference is. I've got a zone valve box showing on screen right now. I'll talk about this and then the differences between our zone pump briefly as well. But our zone valve, we color code the top. So we have R and W, red and white. For most hydronic systems, a lot of people are still using 2-wire thermostats. That's really all you need, R and W. We are providing a common there, which is color coded in blue, is the most common. That's the most common wire for common. And the reason we do that is with Wi-Fi thermostats, we're seeing more and more migration to connected equipment. You need that power wire for most Wi-Fi thermostats. So we've thrown that in there as well. We've color coded the bottom for our zone valve wiring. So if you get our 4-wire zone valve, we've color coded the motor and the end switch, so you know which one is which. And then we've got pump relays as well as an output to turn the boiler on. We are very confident in this product. We put a 5-year warranty on it. And it really cleans up the mechanical room. Now, the one thing I did want to highlight, the differences between the zone pump relays. The zone pump, if you'll notice the image I've got there in the middle, down at the bottom, has a much bigger, let's call it bottom, below the LED display panel. The reason that's much longer is because when you're working with 12-gauge wires, it can get pretty crowded and very difficult to get all your zone valve wire, or I'm sorry, zone pump wires into the bottom of that panel. So we've given you a little bit of extra room to make it a little easier to wire up. And instead of having your 4-wire valves there at the bottom for a zone valve, you're going to have a 2-wire terminal instead to land your pump. We do have wiring books available. We are going to be sending these out for those of you attending. For those of you that are watching the recorded webinar, these are available on our website. So you can go to resideo.com and pull those wiring diagrams, or reach out to your local rep. They've got copies of them as well. When we build upon the basic relay, I do want to highlight our Aquatrol Controls. These are very nice panels that we've had out for a while. They offer some additional features and benefits over our basic hydronic panels. So when you're looking at delivering a very efficient system to your homeowner, this is something I'd suggest looking at. It does a couple of things. One, it's expandable up to 16 zones, literally by linking the panels side to side. It includes zone pump and valve exercising. What that means is it will, even when there's no call for heat from a thermostat or an aquastat, it will periodically turn the pump and the zone valves on and off. The reason it does that is, let's say you've got a system with hard water and you have oxidation, corrosion, et cetera, taking place. If you have a pump that sits stagnant for 6 months and then turns back on and you've got water quality issues, that pump's going to seize up more times than not. So by exercising it, it's essentially going to prevent a level of corrosion that would prevent the impeller from spinning. Same thing with the zone valve. I told you a lot of times in hard water, oxygenated systems, et cetera, we can see that arm on those zone valves seize up. This will essentially open the valves and close them periodically, preventing some of that oxidation. So it extends the service life of the equipment. It also incorporates zone synchronization. Zone synchronization is a really neat function. I'm going to give an analogy here that relates into hydronic heating systems as well. So with zone synchronization, let's imagine that there's 4 of us. I'm going to stay with our 4-zone system example. If there's 4 of us sitting at a table, let's say I'm real dehydrated. So the waiter or waitress comes over and fills up my glass of water. I drink it almost immediately, and then the waiter or waitress comes back over, tops my glass off, and then leaves again. Well, the person sitting to the right of me had already drank 3/4 of their glass, and almost as soon as the waiter or waitress leaves, the person to the right of me finishes it, and now they need water. So the waiter or waitress comes back over, fills his up, leaves, and then I had just finished mine again, so just constantly back and forth. Well, let's put a different spin on this, because this is how we really see restaurant service work. So there's 4 of us sitting at a table, same example. I drink my glass of water. The waiter or waitress comes over, fills mine up, and notices that the person sitting to the right of mine has drank about 3/4 of their glass. So they're going to top it off and fill everybody else's glass up at the table before leaving. So now there's a much longer pause before the waiter or waitress comes back, because I'm still the thirstiest. I'm going to finish mine faster than everybody else. So really, I'm the one that's going to be calling the waiter or waitress to come over, and everybody else's glasses will get filled up at the same time. That's essentially what happens in a hydronic heating system. It's very rare that you're going to have every thermostat calling for heat at the same time as the day goes on. You're going to have solar gain hit certain areas. You're going to have movement that covers other areas. So a lot of times you get one zone calling, then another zone calling, then this one calls again. And so you get just constant cycling on the boiler. Plus, the boiler can only modulate down to a certain firing rate. So even if you have a 10-to-1 firing rate, it's very common that that minimum modulation is more than the boiler can handle, or more than the system can handle. So that boiler just goes on, off, because it's generating more energy than the system can absorb. So by adding zone synchronization, what it does is it allows breaks between zones. And it could be anywhere from 10 to 15 minutes, depending on the system, but it's going to give breaks to the system so that when a zone satisfies and there's no call on the boiler, and let's say another zone calls a minute and a half behind it, it's going to delay the firing on the boiler to essentially give 10, 15 minutes, or whatever it ends up being for the system, time for it to cool back down. A break to the homeowner with an in-floor or most hydronic heating systems is going to be virtually impossible to tell a temperature change. So by waiting, you're increasing efficiency, you're allowing more zones to open, you're allowing better runtime in the boiler. Less wear and tear on the boiler, more efficiency overall for the system. So it's a very, very nice function. It's enabled by a dip switch, which comes from the factory disabled. There are situations you wouldn't want to use it in. So hydro air, fan coils, anything with blowing air, I wouldn't do it, because blowing air cools off and moves very quickly. So any other kind of hydronic heating system, I would enable that zone synchronization. I do want to talk about retrofit jobs. So I get the question more and more. It's coming up all the time as we're seeing an increased conversion into connected thermostats, Wi-Fi solutions, etc., where they've got an existing job. It was run with 2-strand wire, meaning that there's only 2 wires going to the thermostat. The problem is almost all of the options that are out there today require 3. So your Wi-Fi radio is very power hungry. It'll consume a lot of power. So if you don't have that 3rd wire going to it to essentially provide constant power at the thermostat, it is going to just be eating batteries. So we have solutions for that. And I'm going to talk about a couple of different things and a couple of different applications. But this question comes up. I get this call at least once every other day. We have solutions for thermostats with 2 wires. We have solutions for thermostats with no wires. We have connected offering, non-connected. We got lots of thermostat options. But I wanted to highlight one in particular here, because this is a lot of times my go-to. I'm showing you a Vision Pro 8000. This utilizes our RedLink wireless communication, which we've talked about in previous webinars. I'm not going to go into too much depth. If you want more info on our RedLink, we have a previously recorded webinar that you can watch on that. It goes into much more detail than I have, frankly, time to cover on the call today. But what it's going to do is you get the ability with this Vision Pro 8000 to do 2 things with it. You can either hardwire it like a traditional thermostat, or if you use it in conjunction with our equipment interface module, which is shown there in the bottom right, you can make that thermostat operate completely off of batteries. So you can put that thermostat on a wall in any room in a different location where there's no thermostat wire, where it was a bad thermostat wire location, where you want to get on the internet with it, and put the equipment interface module down in the mechanical room. Now, I've got an image up from a project that's got, what do we have, 3, 4, 5, 6, 7 different thermostats. You can put 7 equipment interface modules, 7 thermostats, and wire everything in the mechanical room. No wires needed out in the space. So it's a big problem solver if you need if a homeowner wants to get on the internet, wants to convert to a connected type system, or if the thermostat wire breaks. That happens quite often if there's not enough wires in the wall to make the thermostat work. I do also want to bring up another solution. This doesn't come up as often, but let's say that you're not as fortunate to have zone valves in the mechanical space. Let's say there's zone valves out in the remote areas, or you're using manifold actuators instead of zone valves. And you have to go wireless with all of it. That has come up. It comes up not as often as the previous example, but what you can do with this thermostat is, assuming you can get power to where the zone valve is, which you're going to have power to open that motor anyways, you can put the thermostat on a wall, put the equipment interface module by the zone valve. So what will happen is when the thermostat calls for heat, you now have essentially the back of the thermostat right where the zone valve is. And then you can use what we call an equipment remote module to put down by the boiler to tell it to come on. So it's got a set of contacts that'll close. So the sequence is the thermostat calls for heat, the equipment interface switches some relays to turn the zone valve on. The other module, the equipment remote, will then hit a set of relays that will turn the boiler on at the same time. So we've got wireless solutions to fit just about everything that I've run up against. The RedLink family of products is very powerful, and this package here, I like to refer to this as my Hydronic wireless problem solver, because this has got just about every contractor out of a problem that I've run up against personally so far. Another option, again, staying with that connected route, is our wireless sensors. Or even if you have 2 wires, you could do a wired sensor. But another option for doing that, and we're starting to see more and more of this, especially in the high-end homes, is homeowners don't want to see the thermostats spread around their house. If they've got a job that's got 16 different thermostats in it, they don't want to see 16 different thermostats. We're starting to move more and more to a world where we don't utilize, or I should say where we are utilizing remote controls. Think of your TV. When was the last time you actually walked up to your TV to turn the volume up and down, to change the channel? It's been decades. So we're starting to see that migration, at least in the hydronic world, with the thermostats as well. I know from my own house, I don't think I've touched the thermostat in 6 months. I jump onto our app, I go down to our app and change the temperatures. So the advantage of putting all the thermostats in the mechanical room, or quote unquote hiding them, is if you go to a connected solution, you can essentially give the homeowner a remote interface for their entire system. They can go onto the Honeywell Home app, pop down, select the thermostat that they're looking for, the zone that they're looking for, and adjust the temperature to their heart's desire. So because of that, we get, with some of our Honeywell Home thermostats, we get some interesting solutions. So if you've only got 2 wires, or they want to turn into they don't want to see thermostats, or they just need access to a new zone that they don't want to run thermostat wire, another option is to mount thermostats in the mechanical room and sensors out in the spaces. So again, we have wireless solutions. We also have wired solutions. We have several different thermostats that can be utilized in this application. If you've got questions on what can and can't be used, reach out to local rep. We talk about wireless solutions all day, every day. I want to tie this into your pocketbook now. So when we look at thermostats, I would say the thermostat that's predominantly used in hydronic heating systems is our Pro 1000. We've had it out for a long time. It's a bulletproof thermostat, but it's very, very simple. And frankly, if you're paying, I'm going to put myself in the homeowner's shoes. If I'm spending $30,000 on a radiant heating system, I don't want to look at a $10 thermostat. And I know it's more than that. I'm throwing some rough numbers out. So I've got a couple of contractors that have taken an interesting approach to upselling their customers. I had mentioned that more and more products and more of our thermostats are starting to go to connected. That's becoming a very common trend, not just in our industry, but overall. Connected homes are becoming, that's the way everything is starting to migrate. So I've got a couple of contractors. We came out with our T-Series a while back, and the neat thing about our T-Series thermostats is they use what we call a universal wall plate. I've got an image of it down there on the bottom. But once you wire that up and secure that to the wall, any of our T-Series thermostats can literally pull off and push right on that same wall plate. So what I've got a couple of guys doing is, instead of using their Pro 1000, they've switched to a T1. And we've got a new T3 that's coming out that I think might be a little bit more popular because it's a little more simplistic. But let's just say you utilize a T1. It's a fairly inexpensive thermostat, not much more money than a Pro 1000. You put 4 of those on. I'm using a 5-zone system as an example here. If you put 4 of those thermostats on, your cost for those 4 thermostats is roughly $160. And these are very elevated estimates here, but let's say $160. And let's say you double your sell price or your cost. So you're going to sell it for $320. So you're making $160 off of those 4 thermostats. If you put one Wi-Fi thermostat on, and I'm using the T10, that's my favorite thermostat. You say we're using the T10 Pro as an example. That thermostat cost is $200. Let's just say you mark it up. You don't do the 50% or you don't double it, but let's say you put 50%. So you're going to sell it for $300, make $100 on it. Your profit for the 5-zone system is $260. Because of the universal wall plate, you've got the ability to pop those thermostats on and off without ever having to rewire, unscrew anything from the wall, potentially cause damage to the drywall, etc. What you can do is offer them an upgrade path. Say, hey, I've got you a Wi-Fi thermostat, but I've got an offer here where I can come back in a month or whenever you're interested in, and I can upgrade you to make every single zone in your house connected. What we're finding with this strategy is a lot of people have interest in coming back and getting it swapped out. Once you give them a taste of the Wi-Fi and the fact that they can go on their phone, turn the temperature up and down, adjust things as they want, they can see the temperature while they're sitting in their office. We're in the middle of COVID right now, but let's just assume offices are opening back up. They can see all their temperatures. So once they can see one, they're a lot of times inclined to say, well, I want you to come back and make every zone Wi-Fi. So if you were to do that, offer it for the same cost, it's an additional $400 profit opportunity. So if you can build that into the original sell, that's great, but this is something to think about as a potential profit gain for you, because more than likely you're going to come back up for a service visit anyways to tune the system. So good opportunity to make some additional profit, something to think about. And I've got some contractors who are using this with great success right now.
Thank you, Chris. We appreciate you walking us through the hydronic zoning basics technical training today. You can find information on the products and all that we have covered during our session today at the new Resideo.com website, which is featured on the screen. We're going to transition now to answering some common questions we hear on hydronic zoning. As a reminder, if you do have any questions on anything that Chris reviewed today, please take a few moments and enter that information into the Q&A feature in your Zoom controls, and we will do our best to address any questions in the time that we have remaining. Joining us for our common questions and our Q&A section, we're going to have Michael Ortiz, who is also one of our Resideo water sales reps, join Chris to help answer some of your questions.
So Mike, I've got a couple of questions here. These are questions that we pulled from the team that we seem to get on a fairly regular basis. So starting off, I've got a question here for our hydronic panels. Can I expand them?
Thanks, Chris. Yes, is the short answer. Chris touched on the AQ panels earlier and laid that out as you can expand them up to 16 zones. That also carries with our hydronic panels. We offer them in a 3, 4, and 6 zone configuration on the zone valves and a 3, 4, 6 on the pumps. But they can also be daisy chained together as your project grows and pretty much accommodate any size of project you're doing by doing so. This gives you a common single boiler call, and it also gives you a priority ability off of the control central configuration.
Absolutely. And then I'll reference also, again, that wiring guide. We've got wiring examples that show exactly how to do a lot of this up on the internet. And we're expanding that too. So if you guys come across a unique application or want to see more diagrams, let us know. We're happy to work some of those in as well for you. But yes, Mike, good answer to that question. Another question we get a lot are, what are the different install types and how does that get incorporated into zoning?
You know, the biggest thing we look at there is how are people going to live in the home? And when they put the house together, you know, first floor installation, a lot of them are slab on grade. That's a high mass situation. It takes a little bit longer to respond depending on the floor coverings. So, you know, when you're considering zoning, you want to separate that out so it can live in its own world and give this the maximum amount of comfort. Now, when we get into second story and maybe crawl space or basement installations, we typically have what we'd call a low mass situation. So that's going to be a lightweight gypcrete with tube in it, might be a track product or staple up with reflective insulation, heat plates possibly. Some of the more common construction ones might be the warm board or quick track. So those have a really high responsive reaction time whenever the thermostats are done. So that allows us a little more versatility in those areas, and we can control the comfort. We may even look at doing some setback in there with the thermostat.
Yeah, that's a good point. And to Mike's, to kind of expand on that, there's lots of different ways to install hydronics. So we touched a lot on in-floor. There's also baseboard, fan coils, radiators, lots of different ways of doing it. We got another question here. Mike, can I zone with a slab sensor?
Most definitely. You know, one of the biggest benefits of using a slab sensor is floor protection. You know, we've got a lot of areas that have very high-end hardwood floors. Some of those areas have now adopted codes that require a floor sensor. You know, we look for about an 85-degree max on a floor temperature because our bodies respond to it very negatively once we start getting above that. It's not comfortable to be standing around. I mean, all you got to do is look outside right now and go stand on the concrete for a couple of minutes. And, you know, those temperatures are just not something you want to be on, much less in your home. The other part of that is that we have a T6 model, which is designated to do this type of application. You know, it gives you the versatility to be either sense the ambient, sense the floor, or do both. And this allows for a lot of comfort and a lot of versatility when you're doing your design work.
That's exactly right. And I see the slab sensors used, if they're not required by code, a lot of times I see them in master bathrooms where people might not necessarily care about keeping the room at a certain temperature, but they want to walk out of the bedroom and into a really nice, toasty, warm floor in the bathrooms. So a common spot I see them is in the bathrooms. But yeah, you can use them anywhere. What is a CV value on the zone valves and what does it mean? Mike, I could take this one if you want. So I touched on this briefly already. CV stands for coefficient of velocity. And in layman's terms, it is going to tell you the restriction through the valve. An easy formula to remember is if you're looking at, let's just say a zone valve that's got a CV of 3.5, what that's going to equate to for resistance is if you drive 3.5 gallons a minute through the valve that shows 3.5 CV, you're going to end up with 1 PSI of loss. So when we're looking at pressures in a hydronic system, we typically look at feet of head, not PSI. So there's another formula, if you want to ingrain in memory, is 1 PSI equals 2.31 feet of head. So essentially, if you're driving 3.5 gallons a minute through a zone valve that shows a CV of 3.5, you're going to get 2.3 feet of head resistance through the valve. So they vary. We make zone valves that I've mentioned with a lot of different CV ratings. It depends on what you're trying to accomplish. So I personally like the lower CVs, and the reason is on a residential system, it's very rare that you're going to be driving more than 3.5, 4 gallons a minute through a zone valve. Typically, you see 3/4 supplies that are doing that, and the advantage of using that is you get a much higher blow-by resistance rating. So in other words, your pump is much less prone to pushing that valve open by excessive pressure. Whereas if you use a full port valve or something that has a CV of, let's just say 8, granted there is less resistance through the valve, but it's negligible, and your call it blow-by rating is much lower. So it's very easy, if the pumps aren't sized properly, to push a, call it full port valve open, whereas a reduced port valve will have much less chance of that happening. And then Mike, I've got a question here. What service items do I need for zone valves and zone pumps? So if we've got a service contractor that's heading out to a job site, what's good to keep in the truck?
So because our 1000 series valves have been pretty much bulletproof for years, keeping a power head for that unit is going to take care of the majority of any problem they're going to come across. Now, we also offer 5000 series pop top, which is a much easier off and on. And between those two units, I mean, it's going to take care of probably 80% of your problems. Now, because the motor is a wearable part, it's a good idea to keep one of those on there. It'll allow you a quick dry change out, so you don't have to take out the whole valve to deal with whatever's going on as far as the system opening and closing. So if you really are adventurous and you want to get into the wetted side and you feel you've got an issue on the ball assembly, we do offer that also as a service part. So, between those 3 parts, you can pretty much probably take care of almost any problem you have. And if you really want to be safe, carry a full unit. They're reliable enough that if you needed to take parts out of them, you could replace those parts with some of the service parts you may keep. And in a bind, if you have to change the whole unit, makes that available. As far as our zone pumps go, they've got a 5-year warranty on them. And really, I mean, there's very little to go wrong. As long as the system is kept clean, as long as you maybe have a service contract and you're exercising those pumps, we shouldn't see any seizing on them. So, pay attention to your water chemistry, maybe do some treatment if you need to do that, and get the maximum life out of that pump.
Perfect, thank you. And then the last question, and we seem to get a lot, what's some additional system piping products that help with zoning a system?
So primarily, when we look at a system, we've got 2 component and 2 main plants in the unit. We've got the boiler side and we've got the system side. And a good rule of thumb is let the boiler be the boiler. Let it see the flows it needs to see. Let it control those sides of it that need to happen. There's certain parameters that it's looking for to set temperature, and with these modulating boilers, they're looking for certain conditions and pressures and temperatures. So let that happen. On the system side, we've got all the zoning components we've talked about: the zone pumps, the variable speed pumps, the zone valves, the thermostats and everything that's associated with that. So let that do its thing. Ideally primary, secondary. So at its basis, it's closely spaced tees, and we're drawing off accordingly as we need those loads. As we move forward now into the fall, we're going to be offering a hydraulic separator. This will give you some versatility as far as air elimination, a central place for your system sensor, and also we're going to include magnetic dirt separation. Primary reason for doing this is, you get a buildup of iron oxide in the system and magnetite. That's got to settle somewhere. That's going to settle on your surfaces. That's going to settle in your valves. That's going to settle in your pumps. With the ECM motors now in systems, we're finding that a lot of times this iron oxide will collect in those areas and cause issues. So it's a good idea to sit there and take a step back and look again at your water situation and see what shape it's in, but also give yourself a little bit of insurance by doing some magnetic dirt separation so that we can keep these systems up and going.
That's good. So Mike, you've touched on a second product that we're getting ready to launch that hasn't been publicly announced yet. So again, everybody on the call, you're getting a little teaser here. And Mike, thanks for bringing that up, because I think that'll be a really nice product here in a few months. We're going to go ahead and open it up to questions that have come in during the call today. I've got a couple of them here. So I've got a comment. I thought EIM boards needed to be at least 2 feet apart. I think that question came in referencing an image that I had from a job site that I think showed 7 or 8 of the equipment interface modules. So by definition, and in our installation manual, we've got a criteria saying they need to be 18 inches apart. But with that being said, some people like to push the envelope. If there are issues, we always have to revert back to what the installation instructions do say, though. So best case scenario, do separate those more than was shown in the image. And then I've got another question here. Say you have 2 rooms, 125 square foot each, that are on the same hydronic loop. Can you zone them differently with T10 sensors? Mike, do you want to answer that, or do you want me to take that one?
No, I mean, I can pick that up. Okay. Unfortunately, because we have a single source of where we're bringing in the hydraulic fluid and dispersing it over those 2 rooms, we can't really split that into 2 zones. However, with the T10 and the sensors, we can do some averaging. And so that is going to allow us to look at the loads in those 2 rooms and be able to kind of equalize, what's available and where they sit at. But it's not true zoning at that point, but it is at least closer to the comfort probably that we're looking for.
That is accurate. Yeah, a lot of times we've called the T10 kind of the zoning without zoning. So the averaging will help, but ultimately, unfortunately, yeah, you can't break that up. I think, are there any other questions? I think that's the last question that has come in.
Thank you, gentlemen. We will close it out for today. Thank you both to Michael and Chris for answering those questions. And Chris, a big thank you to you for providing that technical overview on hydronic zoning basics today. Please make sure to join us every week on Tuesdays at 2 p.m. Central Standard Time for our Resideo customer webinar series. Next week, we are featuring a training on non-connected thermostats, and we're going to give you the first look at our E1 Pro and T3 Pro non-connected thermostats. So please be sure to share the details of that training with your teammates or coworkers and join us next Tuesday. And then to find information on our upcoming series of webinars, please visit resideo.com/webinars for more information, as you can see here on the screen. And then just one final reminder to those contractors who did not include your NATE ID on your registration form and you would like credit for today's session, please go ahead and send your first name, your last name, and your NATE ID to homes.university@resideo.com within 1 week of today's live webinar session to receive credit for attending today's live training. And then 2 final things to note before we close here today. Once our training session ends, you will be prompted to complete a survey regarding our webinar session. So please take a few moments to provide us with your feedback on the training that we went through today on hydronic zoning. We are looking forward to offering additional online webinar sessions going forward, and we want to hear your feedback on today's session. And then we will also be sending an email in a few days that includes some follow-up information on the details that were discussed today in our webinar, as well as a link to the website for more information on our future webinars as well. Thank you all for joining us for today's Resideo webinar session on hydronic zoning. Please join us next Tuesday at 2 p.m. Central Standard Time as we cover non-connected thermostats. Have a great day, everyone.